In this video, we're going to learn how to add and subtract like radicals. So we're going to start off by learning what a like radical is. A like radical are two radicals that have the same index and the same radicand. So for example, the square root of 2x is a like radical with 3 square root of 2x. They are both square roots and their radicands are both the same. So let's go ahead and work some examples of how to add and subtract like radicals. You can notice in the very first example that the index 3, they are both cube roots, and their radicands of 3x squared are the same, so these radicals are like radicals. So in order to subtract them, we subtract the numbers that are in front of them, like this. 2 minus 6 is negative 4, cube root of 3x squared. That is our final answer. You can notice that in the second example, we have the square root of 19 and the square root of 19. Those two radicals are alike, but this last radical is a cube root. Therefore, it is not like with the first two. So we'll go ahead and add the numbers that are in front of the first two. Negative 7 plus 5 times the square root of 19, and we still need to subtract this last radical. It can't be forgotten. So when we add these two numbers, negative 7 plus 5, we get negative 2 square root of 19 minus 4 cube root of 19, and that is our final answer. Let's move on to a couple of problems that are a little bit more difficult. In this example, you can see that we have what appears to be two unlike radicals, but if you really take a close look, you'll notice that these radicals can be reduced. So let's go ahead and reduce these radicals. We'll rewrite them in terms of their prime factors. 27 is 3 times 9, and 9 is 3 times 3. We have a group of 2 of the same number, so we're going to go ahead and pull that out to reduce it to 3 radical 3. The square root of 75 is 3 times 25, and I know that 25 is 5 times 5. I have a group of 2 5s, which I'm going to pull out of my square root because I'm looking for groups of 2. So I end up with 5 square root of 3. And now you can see that I have two like radicals. So I will subtract the numbers that are in front of them to get negative 2 radical 3 as my answer. So in this next example, I notice that this last radical is reduced. 5 is prime, and I can't take the square root of x because I have no groups of 2 when I only have 1x. So we're going to take a look at this first radical, and we're going to have to reduce that. So I know that 45 is 5 times 9. 5 is prime, so I'll write it. 9 can be broken up into 3 times 3. And then I have x times x times x. That's what x cubed is. So I'm going to circle my groups of 2, and I notice that I have two groups of 2, 2 x's and 2 3's. So I'll take one of the 3's and one of the x's out and multiply it by what's in front. 3 times 3x is 9x. And I have a 5 and an x remaining under my radical, plus x radical 5x. And now I can look and see they're both square root of 5x, so they are like radicals, but I have to check the variables in front of the radical to make sure my terms are alike. I have the same variables with the same exponent, so now I have like terms. So now to add them, I just need to add the numbers in front, and there is an implied number in front of this 1x here, and that implied number is 1, so we can't forget that. So we have 9 plus 1, x times radical 5, which gives us 10x radical 5. All right, let's move on to something maybe a little bit more difficult, but not too bad. Let's take a look at these two examples. So when we take a look at these examples, we fully notice that all three of these radicals are not like radicals. So what can we do with these radicals? Let's try and reduce them. I know that 32 is 2 times 16, and 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. I'm looking for groups of 2, so I have 2 groups of 2. All right, so I'm going to pull those two 2's out. How about radical 18? Well, 18 is 2 times 9, and 9 is 3 times 3. So I have one group of 2 here. And now 128 is going to be a big one. Plus 2 times the square root of, well, 128 is 2 times 64, which is 2 times 32, which is 2 times 16, which is 2 times 8, which is 2 times 4, which is 2 times 2. How many groups of 2 do I have here? I have 3 groups of 2. So I get to pull 3 groups of 2 out of this problem. So when I reduce this first radical, I get 4 times 2 times 2, which is 16 radical 2. When I pull out the 2 3's, I pull one of them out and I get 3 radical 2. And now when I reduce this last radical, I have 2 times 2 times 2 times 2, which is 16. And I can't forget I have this 2 left over, so it goes under the radical. And you can see that all 3 of these are like radicals. So we'll just add and subtract the numbers in front. 16 minus 3 plus 16 times the square root of 2. And when I add and subtract these numbers, I get 29 square root of 2 as my final answer. Next problem. I have the square root of 4x to the 7. And I know that 4 is 2 times 2, and I'm just going to leave x to the 7 here because I can see I have 3 groups of 2x's with 1 left over. Here I have 9x squared, cube root of the square root of x cubed, and then I have 5x square root of 5x to the 5th. All right, so here I have a group of 2 2's, so I'm going to pull one of those 2's out, and here I'm going to take out 3 groups of 2x's. So 3 groups, and I have 1 x left over. Here I'm going to pull out 1 group of 2x's, so I end up with x cubed on the outside and an x under the radical. Here I'm going to pull out 2 groups of 2x's, so I end up with x cubed square root of 5x. So I notice in the first 2 terms I have the square root of x here, but in this last term I have the square root of 5x, so this is not a like radical, so I won't be adding it to the other 2. So when I add these 2, I have to check the variables in front. They are exactly the same, so they are like terms. So I add 2 plus 9. I have an x cubed radical x minus 5x cubed square root of 5x. When I add these 2 numbers, I end up with 11x cubed square root of x minus 5x cubed square root of 5x as my final answer. So those were the 2 hardest problems we've done so far. So let's take a look at our last 2 examples. One of them is a fraction. So I notice I have the cube root of 4, and I know 4 breaks down into 2 times 2, and that's it. I don't have any groups of 3. But I do notice my denominators are not the same, and I know with fractions I have to have the same denominator. So in order to add these, I need to have a common denominator, and that common denominator is 14. So I'll multiply this first fraction by 2 over 2. So in the numerator I get 4 cube root of 4 over 14. And remember, there's always a hidden number in front of either a radical or a variable, and that number is 1. So for the second fraction, I have 1 cube root of 4 over 14. So when I subtract these two like radicals, I have 4 minus 1 cube root of 4 over 14, which is 3 cube root of 4 over 14. And this last example that I have for you, none of these radicals look like they're like. So we're going to have to simplify them. But now we're looking for groups of 3. So how does 24 break down? 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. And then I have an x cubed. So I have my group of 3 2's, and I'm going to pull one of those 2's out. All right, so how does 81 break down? Well, I know 81 is 9 times 9, and both 9's are 3 times 3. So I have one group of 3 3's that's coming out. And then I have my last, which is already reduced. 3 is already prime, and it does not reduce any further. All right, so now I just need to simplify these. I have 6 times 2, which is 12. And then when I look at my variable, the cube root of x cubed is just x, because I have 3 x's, which is a group of 3. And when I reduce that all the way, I get the cube root of 3. When I reduce this next one, I have negative 2 times 3 is negative 6. Again, I have x cubed, which is a group of 3 x's. So I pull one of that group out. And then I'm left over with this 3. And now I have an x times the cube root of 3. And when I'm done, I notice that all of these are like terms, because not just the radicals, the index and the radicands of the radicals are identical, but also the variables in front. I have all x's. So I'm going to add and subtract the numbers that are in front. And remember, again, we have a missing number. It's assumed to be 1 minus 1 x cube root of 3. So what's 12 minus 6 is 6 minus 1 is 5 x cube root of 3. So have this video handy when you're doing your homework.